Good morning, my fellow scientists. It is Friday, March 31st, 2017, and I'm excited about science again. There's nothing like getting in the lab to make a man forget his troubles, especially when those troubles are completely outside his control, such as whether there's going to be funding from the National Science Foundation next year. Call your Congress people. Anyway, the project I proposed to some students yesterday, I suggested that they should maybe try to build an index of refraction detector. So I mentioned the idea in the old vlog yesterday, where the material inside a little microfluidic prism should change how light is refracted through that prism, and we should be able to detect that change with image analysis by calculating an angle, or with just a photodetector, depending on if that angle aligns the beam with a photodetector or not. So we tried it. So we cut a little triangular prism and we shot a laser through it, and then we changed the medium inside that prism and we tried to calculate just how sensitive we could be. It's not yet a microfluidic detector, but I think it proves the principle, and I want to show you the video because it looks pretty cool.
So this is just the first step. I don't know how well you can see there. I seem to be having a bit of trouble focusing, but this little piece of acrylic has been cut with a roughly equilateral triangle in the middle, and if we move this little prism made of air to the space in front of a laser, it does cool things. So that air is refracting the light as the light hits the corner of that prism and sending it off in that new angle. So the angle between this spot and this spot is dependent on the medium of that little prism. So if we change the medium, we should change the angle. Let's try that. Now we're going to try filling this with water, if I can do it without getting water everywhere. And this changed so that it's now hitting the ruler at a substantially different angle. And if we pass different fluids through such a little prism, we should be able to detect different compounds as they transit.
So clearly the angle of the refraction depends upon the medium that's in that little prism, so we should be able to detect changes in that material due to chemistry as a function of time. We just need to figure out now it's just a matter of figuring out the electronics, which that's its own fun problem, but we'll get there. After that, we need to integrate with a separation. I'm thinking we will try electrophoresis because that works so well in fluidic chips like this. We'll try to get a movie of something that you can see electrophoresing through a system like this. That'd be pretty fun. And then we'll try to integrate with the detector. So that'll be great. I'm going to start doing more on the battery stuff here at the Allen Lab vlog. So if you're interested in that kind of thing, shoot me an email, shoot me a comment, and give me some feedback on what you'd like to see. And we'll try to build a battery here live for you all next week. Until then, I hope you have a great weekend. Check me out at peterallenlab.com. Do I want to say check me out? I don't want to say check me out. That's weird. For more science, chemistry, microfluidics, and frickin' lasers, tune back in here on YouTube or head over to peterallenlab.com and you can read more about the kinds of things we love to think about here in the Allen Lab. Until Monday, have a great weekend.